In today's video, we're going to look at how we separate metals from their oxides, which is how we typically find them in the real world. First though, we need to cover the terms oxidation and reduction. Oxidation refers to the process of gaining oxygen. For example, if we combined magnesium with oxygen to form magnesium oxide, we could say that we oxidized the magnesium. Meanwhile, reduction is the loss of oxygen. So if we broke our magnesium oxide back into magnesium and oxygen, we would have reduced the magnesium. Now, as most metals are fairly reactive, when they're exposed to oxygen, they'll oxidize into a metal oxide. For example, iron naturally reacts with the oxygen in the air to form iron oxide, which is more commonly known as rust. And because oxygen is so abundant in our atmosphere, most of the metal on Earth will have come into contact with it at some point. And in most cases, as long as it's left long enough, the metal will have been oxidized. The exception to this rule is the really unreactive metals, like gold, which we often find as pure metals, because they're too unreactive to react with oxygen. Remember that we do find metals bonded to other elements as well, but being bonded to oxygen is the most common, and you need to know how we can remove this oxygen to get a pure metal. We saw at the beginning that reduction means the loss of oxygen. So essentially, we're trying to reduce our metal oxides to get pure metals. The cheapest and easiest way to do this is to react our metal oxides with carbon. The idea is that the carbon will basically take the oxygen from the metal to form carbon dioxide and leave behind a pure metal. For example, copper oxide plus carbon reacts to form copper plus carbon dioxide. So we would say that the copper was reduced because it lost oxygen, and the carbon was oxidized because it gained oxygen. Unfortunately though, we can't do this with all metals, only the ones that are less reactive than carbon. And this is the reason why we place carbon in our reactivity series. We can see from this list that we can use the reduction with carbon technique to extract zinc, iron and copper from their oxides. But we couldn't extract any of these more reactive metals. For these ones, we'd have to use a process called electrolysis, which we'll cover in another video, but basically requires loads of energy and so is really expensive. As a last example of using carbon, let's imagine that we were mining for iron. As we take the rock from the ground and separate out the bits that contain iron, we'd find that we have lots of different iron ores, with ores referring to metal-rich compounds that we can extract our metal from. The most common ore will be Fe2O3, which is a type of iron oxide. So to isolate the pure iron, we need to reduce this iron oxide to just iron. If we check our reactivity series, we can see that iron is less reactive than carbon. So we're able to do reduction with carbon rather than having to do electrolysis, like we would with these more reactive ones. So to write this as an equation, we take our Fe2O3, add some carbon, and as long as we supply some heat, it will go to form pure Fe plus carbon dioxide, which we can balance like this. Anyway, that's all for this video, so if you found it helpful, go ahead and give us a like and subscribe, and we'll see you next time.